Hello everyone. So we're gonna solve LeetCode 2.0 exam, which is implementing a trie, which is PREFIX tree. So let's understand the problem first. So basically, in this problem, you have to I just written this in the previous one. So yeah. So in this, like you have to basically complete three functions. One will be insert, search, and starts with. Okay. So before understanding what does like these three functions do, let's understand what is basically a trie data structure. So try is like basically what you do is that in try you try to show as many of strings as possible without without using separate let's say you want to store abc and other word will be abcdefg something. So like there is a redundancy, right? Like ab and ab of both the strings are same. Let's say you want to let me give you an example. Let's say you want to store aa dbb, okay, and like there are like other strings such as AA, and some other stuff, let's say. So here you can see that like the prefixes of both the strings are same. So like why you want to allocate different memory spaces? Why, like you can just basically use the allocated memory to here. And there are lots of other benefit to it. Let's say you want to do a search and you want to see that is there word, let's say this word is present in your data structure or not. So basically, you can just look for A. After that, you can like go down the tree and look for B, C, D, E, F, G, like whatever, and go look for a target word. So prefix tree has lots of applications such as like whenever you type a word on on your keyboard and it suggests you like it give you word suggestions. So those are done using prefix tree. So basically, so let's understand it a bit more clearly. So basically, prefix tree is a custom object or data structure which we define by ourselves. In C++, you can like in C or another language you might define structure, and in Java or other based languages you will define classes. So basically, like that custom object has two parameter, or you could say two objects, which will be boolean is and tree node, like array of tree nodes itself. Okay, so like Boolean is and basically is used to define like whether the word ends here or not. Okay, and try node it is an array of size 26. And why size 26? Because like there are only 26 characters in lowercase English letter. That's why we are using allocating it size 26. Okay, so I stole this from GFG. So uh, because I don't have crash pad or to explain, so I will be using their trick to explain it. So let's understand one by one. Like these are the words which we have to insert into our data structure. Okay. So what we can do is that first let's pick up the word and we have to insert it. And root node, basically root node will be having like this array. Like root node will be pointing to towards the the words which have been already entered. So like in this case, like in this tree, you can see that the word A and D, the word which starts from A and D has been entered. So all the other position of children array will be null except for A and D. Okay, and they will be storing the addresses of their own children nodes. Okay, so let's insert word and first. So starting with the A of and, what we do is that first we look that like is there null on eighth position. If there is null, then we just insert that word. Like we basically create a new node and allocate it that we just allocate we give we point towards that newly created try node. So let's say like first you insert A. So what you basically do is that like is there a null? If there is no null, then you're gonna create new node and you're gonna make connection between these nodes. Okay. So now A will be pointing to this, but now let's say you want to add n. So you again you will be start like from here you will look for is there word uh, like after like you have traversal till n a. After you're gonna see that and it is pointing to this node. Okay, then you're gonna check the does nth position, like the word where n should be positioned, like does that contain any trinode? If it does not contain a trinode, then create a new trinode and make a connection between them. So here we will be creating like let's say n is here somewhere, and we just create a new trinode. Okay, and then it comes to D, then you're gonna check here like does D have any null values, or is there any other previously traversed trie node? So similarly, of course, it doesn't have. So we're gonna just create a connect like new trie node and connection between them. Okay. Now let's insert. So and we can see that D is the last character of that string. So basically, what we can do is that we have one more like boolean function which is that is and. So we can mark it true. So basically, what does that represent? That represents that the word A and D ends here. Okay. So that is the use of is and, by using that we basically mark the end of any word. Okay. So now let's enter word and here we can see that we have two common prefixes. So again we're going to start from our root node and check is there any null value on eighth position. So of course there is no there is not any null position. Uh, we already have an address of another panel. So then again we're going to move to this node. So like basically we're gonna, if there is null node, then we're gonna create a new node and make a connection. If there is no null node, then we're gonna go to we will go into depths of that trie node. So yeah, here A, so it is not null. So we're gonna travel to the trie node where eighth position is pointing. So it is pointing here, and we're gonna check on nth position is there any null node. So there is not any null node. So what we're gonna do is that we can again travel to here, and we can check on position T, is there any null node. So yeah, of course there is null node. So what we're gonna do is that we can create a new node and point it towards here. I hope you got this. And like T is the last character, that's why you're gonna just mark it is and that's it. So that's how trie data structure works. So here also you can see that first we entered word character A, then we moved down and down till we exhausted our first string. Then and then like second string had few common prefixes. So we basically like we didn't allocate new space for those common prefixes. We just use the previous space and uh, like there during in the case of T there was no previously occupied trie node, so we basically created new trie node and mark that node as the end of word A and T. So now let's get to the coding part. So first basically we have to define our trie structure. So let's call it trie node boolean is and trie node array which will be children. Let's call it children. Which will be trie node. And it will be of size 26. So like you need to store the value of your head pointer, right? So you can make your head pointer as a static variable or a global variable. So whenever this try class this function this method is called, then we just allocate it a new timer. Okay. Now let's come to insert function. So in the insert function, what you have to do is that you have to use simple for loop and travel through each character. Okay, so for I equal to 0, I less than, I will have to call it s dot n, of course, and let's say ch equals to s dot add, and like we can capture our head node into node equals to head. Like we don't want to lose the address of our head, so that's why we are creating a temporary node which we will be using for traversing through the our trie structure. So so if node dot ch minus a equals to null, then as I told you, like at eighth position, the first character, let's say in this case it is a, If there is null, then we have to basically create a new node, which will be like try node and new node equals to new try node, and like this try node should be, and like after creating a new node, what do we basically have to do? We have to create a connection between them, right? So, and connection will be like this only, using this equals to new node. Now, now what we have to do is that we have to basically go into depths. Like if there is a null, then we have to basically create a new try node, and we have to search in the newly created try node or the try node which is into depths, right? So basically, what we can do is that node equals to node of ch minus a. And why I'm doing ch minus a, that it should be like that. Basically, like if you a minus a will give you 0. So like ath character will be pointing towards 0th index. A minus b will give you 1, and bth character will be like, if character is b, then it will be pointing towards first index. So that's how we are converting our characters into the indexes. Okay. And like at the end of this, you have to mark node dot is and equals to true. Okay. And now what you have to do is basically we have to search for exact word. We don't want prefixes. Okay. So what you can do is that use the same code from the above. Like, that is the best part of try. Like, you have to write only insert function, and using that insert function you can do like small changes and reuse the same, like almost same code. Like here, search, what you have to do is that like if there is null at that character, that means that word doesn't exist, right? So you have to just return true here, so return false. In the case of insert, we were basically creating a new triangle. In this case, if there is null, that means that word doesn't exist, right? Only, like in that case only, you will be having null, right? Or else move forward into the depth of tree and return is and true or not. Like, let's say you have inserted word apple, then you search for word app. So wouldn't find any null values in between, right? Like a exists, double p also exists. But in the end, you also have to check that like a double p, like the last p or the last character of word which you're looking for, is that end word or not, end character or not. So that's why we are using it. And like starts with. So similarly here. So if there is null value, then just return false or else return true. Why here true? Like, let's say you want to search for word app. Here also, like you want to sorry, you want to see if there is any word which starts with a double p, which is app. So like in this function only, they are asking for that kind of situations where the word should start with that prefix. Like, they are not looking, okay, is there exact similar word in your structure or not. That's why we are just returning true. Or else if there is null in between, so return false, obviously. So let's go this. There will be also compilation error. Yes. It is another copy and pasting the same error which running can be transferred to the other parts. Let's run it. Yeah, so after solving like thousands of compilation error, we have successfully submitted our work. So that's all from my side.